Alright, question 5. What is the internal resistance of a 12-volt car battery whose terminal voltage drops to 8.8 volts when the starter motor draws 95 amperes? And also then what's the resistance of the starter? Okay, so we have a car battery and we've got something that it is running, which is a starter motor in this case. Now normally we would draw it like this. We would just say, well, I've got some battery and it's running something with a certain resistance, and there it is, and I've got a certain voltage here and I've got a certain resistance there. That's normally what we would do. And then the voltage is given over these terminals, between the terminals of the battery in the circuit as the current is flowing. However, the key word here is internal resistance. What is the internal resistance? Now, if we want to consider the internal resistance, then instead what we do is we look at the circuit that looks as follows. Right, so let's start by, okay, so this question 5. So then what we do is we say what this part becomes is we've got a point A, we've got a little resistance R, which we use to denote the internal resistance, and then we've got the so-called EMF of the battery, the electromotive force it's called, an outdated but historic term. Okay, and the starter motor is out here somewhere. It's got certain resistance R. Okay, so there's the starter motor with resistance R, and this is our EMF. Okay, so the thing is, the EMF, this Xi, it's XI, that's how you spell it, is 12.0 volts, and this whole thing is now considered to be the car battery. This entire thing. No, we wouldn't draw a block like this, and no, this is just to indicate it for purposes of answering explaining the problem. Okay, so this whole thing would be considered the car battery. That is how you model the internal resistance. You've got a perfect 12 voltage source, but it is hampered by the presence of extra resistance. So this VAB, where A and B are the two terminals of the battery, the potential difference measured over them is 8 volts, 8.8 volts, and that is when the current, which direction is the current? That's positive, that's negative, so it goes around from positive to negative. There, that is the current. When I is, how much did I say? Is it 95? Yeah, 95 amperes. 95 amperes. Okay, so no current, then you can measure 12 voltage difference over the battery. But as soon as a 95 ampere current flows, the voltage drops down to 8.8 because of the internal resistance of the battery. And this is how we model it if we want to take into account the internal resistance of the battery. So this whole thing, this approach, this is for internal resistance. So I knew I was going to go that way when I saw this keyword, internal resistance. Right. Okay, so now what is little r? Little r, lowercase r, this is the internal resistance of the battery. And R now, big R now represents the resistance of the starter motor. So let's just call it the starter motor. Good. Okay. Alright, okay, so now what do we want? We want the resistance of the internal resistance first. Okay, so what do you use? This formula we did in class, which relates the voltage over the terminals with the EMF of the battery in terms of the current and the internal resistance of the battery. So that's what you use. It's just a direct application of that formula. VAB, potential difference over the terminals, is the EMF minus the current times the internal resistance. What am I after? I'm after this little r, so let's get that by itself. IR is equal to VAB, so the internal resistance is the EMF over the current. There we go. Okay, now I just substitute. So that is 12.0 volts minus this 8.8 volts over the 95 amperes. Okay, we calculate that to find, so 12 minus 8.8, so that would be 3.2, right? That divided by 95, that is, okay, there we go. We're not going to use this in subsequent calculation, so I'm just going to provide this as a final answer then. So how many significant digits? Okay, so there's multiplication, division going on, and divide. So I'm going to look at the least number of significant figures. That's 95. It's 2. So I'm just going to provide 2 significant figures. Okay, so how do I write that as 2 significant figures? Okay, I can write this 3.4, or I can just write it as 0.0334 ohm. There we go. Good. So that is the internal resistance. Now the question also asks for the resistance of the starter, so thereafter the value of R. Okay, so now this is again as was explained in, I believe, the first question. When we draw a diagram like this, we consider these conductors to be perfect, and there's the voltage here would be the same as the voltage there, and the voltage here would be the same as the voltage there. So that means the potential difference, the voltage over these 2 points would be the same voltage over those 2 points. So the voltage VAB would be the voltage over this big R, over the starter motor as well. Right. So I can just use VAB equal to IR. So what am I after? R is equal to VAB over I, and this is just 8.8 volts over 95 amperes. Okay, and that gives us what? Sure, what should this answer be approximately? Well, if it was 88 that we divided by, then 8.8 divided by 88 would be 1 over 10.1, right? But we're dividing by a little bit more than 88, 95, so it should be less than 0.1 at least. Okay, so yeah, so that's more or less what we expect. A good habit to develop to more or less expect what the answer is going to be. And I'm also going to provide 2 significant figures, so 0.093 ohms. Right, and that's it. More the internal resistance, which makes which seems right. Right. Okay, that's question 5.